Here is the key for homework 1. The first question, drawing all non-zero formal charges. This is very similar to Skill Builder 1.7 and 1.8 and the related questions around there. So the first question, the first structure has no formal charges. The nitrogen, 3 bonds in a lone pair, all the carbons are good. So we'll move on to the next one. Then our attention should be drawn to this nitrogen. That's a negative charge. 2 bonds and 2 lone pairs gives it a count of 6. It wants a count of 5, so it's a negative charge. Then our attention should be drawn to this oxygen in the middle. 3 bonds and a lone pair means it's plus charge. We should be very familiar with those patterns at this point. And then the carbon here is negative. It's got 3 bonds and a lone pair giving a count of 5 electrons. It wants 4. And lastly, the oxygen here is negative. 3 lone pairs in a bond is always going to be negative. This question 2 is actually from chapter 4. I made a mistake there, so we'll do that on chapter 4. That brings us to question 3. And question 3 is out of chapter 2. Skill Builder 2.8 would be a good review and the various questions associated with that Skill Builder to practice. Number 3. This is probably the most difficult question on the exam. I'm going to switch to my better drawing program to look at these resonance structures here. So we're asked to draw all relevant resonance structures. And of course, it's a good idea to either mentally add the lone pairs or fill them in. Some students lost a few points because they forgot about this lone pair. So probably a good idea to start, at least, with these questions by adding the lone pair. There's a couple directions we can go with these resonance structures. The first one I'm going to observe is this cation has a alkene on both sides. So we can do 2 different allylic cation arrow pushes. And so the first one would get us to here. And I'm actually going to push this structure down. You'll see why in a second. And that gives us the alkene right there, and we leave behind a hole in the electron count on the far left of the molecule. Now I could also do the other allylic cation, and that's going to be that faint arrow there, just so we don't get confused. And actually, let's try to use a faint arrow here, just to try to keep track of what we're doing here, just so those arrows look different. Alright, so if we follow that, we get to this structure. Lone pairs there, plus charge. And now we have this new structure. And here we have lone pair next to a cation is the resonance pattern we observe. And that's just a single arrow push. And so it's going to get us to this 4th structure. Let's just put a giant line there so we keep track of where we are. So this is the 4th structure. There's a double bond now to the nitrogen. It still has 2 hydrogens, and that gives it a plus charge. And so each of these has a plus charge. Some students lost points because they created charge somewhere. They started, of course, with this molecule, but at some point their molecule, I'm just going to put a squiggle here, had a minus charge somewhere. And overall it was minus. If we add up all the charges, it should still be plus 1, just like we started with. But if somebody puts a minus and they have a plus over there, now we add up to 0. We've changed the charge. That is impossible to do when drawing resonance structures. So that's a good check that you can make. Do not ever have a different total charge count than what you started with. And some students maybe had a 0 charge count. No charges at all, and that doesn't make any sense either. So either you just didn't fill in one, or you didn't observe some charge somewhere. Some students would draw, so these are the 4 that we want. These are all correct. I'm going to start to mess these up and show you some incorrect ones. But first, let's draw the resonance hybrid. And as we said in class, we're going to draw the single bond structure. And then we're going to put a dashed line anywhere there's a double bond. So there's 3 double bonds here. There's a double bond then right here and right here. So we basically have double bonds all along this structure. So I'm going to have a zigzag double bond all the way up to the nitrogen. And then I'm going to put delta pluses wherever I found plus charges. And there are 4 of them here. So this is the proper resonance hybrid. It's basically an average of all 4 of the resonance structures. And actually, this is more appropriately put brackets around our resonance structures here. So the resonance hybrid is right here. It is an average of all 4 resonance structures. So let's talk about some mistakes that students made. Some students took that lone pair and just pushed it down. And that means they forgot that there was a hydrogen there. So if they push that lone pair down without doing anything else, they end up with this structure, which I hope looks weird to you. If we count the formal charges, those are we have new charges here, but also, more importantly, we have 5 bonds to carbon. That's never going to be successful. You're never going to get credit if you draw something like that, so try not to do that. I didn't see very many students show this, but sometimes students will take the cation and move it around. The cation has no electrons, so it will never be moved by an arrow. It can be created by the absence of electrons, so when we move electrons away from somewhere, we could create a cation, and thus it might appear to move, but this arrow will never happen, so let's get rid of that. This is a poor drawing here. Some students got to this structure and forgot about this final pattern, so they didn't observe the lone pair next to cation pattern. So it really takes a lot of attention to detail to do these resonance structures, and we're not going to do resonance every week for the rest of the semester, but there will be times where it will be very useful, and we'll see one of those times in Chapter 3. We'll see another example of that in Chapter 8 and 9. Alright, so let's go on to the second part, the second resonance structure, and it actually looks very similar. We've got a number of double bonds. In this case, we have a negative charge now instead of a positive charge. So now we have an allylic anion, and of course we could draw this, and some students forgot the second arrow, but if you don't draw the second arrow, you're left with a pentavalent carbon, and I'll show you that again. So I'm going to draw this one going down, and there's my new resonance structure. And of course the other one looks like this, and I'm going to use faint arrows for that just to keep track of them. And there's my new structure. It has a negative charge overall, just like the starting material had a negative charge overall. I didn't create any charges. These are the only structures that we can draw here, so let's draw all 3 of those. And of course the hybrid will look like this. Single bonds. And then wherever we found a double bond, we put a dashed line, and that's going to be again over the whole structure of the molecule. Delta minuses wherever we had a or wherever we had a negative charge, just like that. So that's the hybrid. It's important to recognize that there are 2 directions we can take this negative charge, both of which are essentially allylic anions. Some other students came up with this structure, which isn't necessarily wrong. It's just not as useful as the 2 additional structures I showed you. Here we have 3 charges. That we've created 2 more charges. We still have an overall negative charge on this molecule, but the problem is that we've created these 2 new charges, and that makes it a very much more unstable situation. So this isn't really a highly contributing structure. If you drew this along with the other 2 that I showed, I would give you full credit. But if you left off one of the other 2 and just had this one, you wouldn't get full credit for this question. And again, Skill Builder 2.8, along with the associated questions, both right after that Skill Builder and in the back of the book, can give you some good practice for these types of questions.